Okay, now if we replace the square here with a cube, things change a little bit, okay? First of all, our y-intercept changes because if we plug in x equals 0, we get -1 times 1, which is -1, and then that's times the cube of -2, okay? Now -1 times 1 is -1, 2 cubed is -8, and -1 times -8 is 8. So the y-intercept is 0, 8. Write that out if you have to. Just write zeros in there and evaluate it. Okay. Our zeros are still -1, 1, and 2. It's obvious that these are the only values that will make this product 0. If x is to the left of -1, then this is negative and this is negative, right? Wait, whoa. If x is to the left of -1, that's negative. Yeah, and that's negative. Okay, yeah, lost my train. Okay, and then x minus 2 will also be negative because -1 minus 2 is certainly negative. So we have a negative times a negative times the cube of a negative. Well, the cube of a negative is 3 negatives, that's negative. And then we multiply that by a negative, it's positive, but we'll multiply that by a negative and it's negative again. So we know that the graph, unlike this one, is going to come up from below. If x is greater than 2, if we're to the right of x equals 2, then all these are positive, so when we multiply them together, it's going to be positive, so we're going to be up here. Okay? So we would be tempted to draw the graph like the white graph I drew here, and I'll kind of show you where that one went. Okay, that one was kind of like this, right? And yeah, that wouldn't be too far wrong, but it kind of messes up in the vicinity of this point because, for the same reason, we had a parabola, or at least we were close to a parabola when x is -2, and when x is 2. We're going to be close to the graph of a cube when x is at close to 2. So that what we're going to have here is going to be some transformation of y equals x cubed. Okay? And actually it acts like 2 times x minus 2 cubed. 2 here for the same reason, we got a 2 here. And x minus 2 because of course that is the position of the 0. So that's a transformation of this. The x equals 0 point of this will, this will get stretched by factor 2, but that'll leave the behavior at the x equals 0 point pretty much the same. It's going to kind of flatten out there. And then we shift 2 units to the right, it's still going to have that same general shape. It's just going to be stretched out a little bit. So it's going to look like this at that point. Okay, now there's a rule that kind of summarizes everything we did here without necessarily inspiring you to understand why. I think you understand the rules better if you understand why, so I've explained it, but I'm going to just tell you the rule.